Number 3. The integral of 2x plus 4 over x squared minus 6x plus 25. So what do we need to do? We need to put this into a form. This is a quadratic. We're going to complete the square. We know this will be x squared minus 6x plus 9. So then 9 plus 16 will give us our 25. Now we can write this as 2x plus 4 over x minus 3 quantity squared plus 16 dx. Let's set up our right triangle. So we have x minus 3 will be on our vertical, 4 will be on the horizontal, and then we'll have x minus 3 quantity squared plus 16 on the hypotenuse using the Pythagorean theorem. Let's define our trig function. We'll have tan theta equals x minus 3 over 4, or 4 tan theta equals x minus 3. Note we're going to need to solve for x here, so we could just do that right now. Make sure this is focused. So we have x equals 4 tan theta plus 3. Now we're going to need the expression for the bottom, and that will be 4 secant theta equals that square root, x minus 3 quantity squared plus 16. We don't have the square root in the original problem, so let's square both sides. Let's see, what else do we need? We need a dx. And so this would be 4 secant squared theta d theta. Now we can substitute everything in. So we have 2 times x, which is 4 tangent theta plus 3. And then we'll have plus 4. That quantity will be multiplied by dx, which will be 4 secant squared theta d theta. And then all divided by 16 secant squared theta. So let's reduce out the secant squareds. We can reduce the 4 and the 16. Now, just so we don't get lost, let me just write what we have. I'll multiply it out, and then we can reduce whatever's left. So we'll have 2 times this, which will be 8 tan theta, and then 2 times 3 will be 6 plus the 4, which will give us 10 divided by 4, and then we have d theta. So now let's take out a 2 here, and we're left with, or we could just break it up into 2 separate fractions anyways, because we're going to have to integrate them separately. So we'll have 2 tan theta plus 5/2 d theta. How do we integrate this? Well, 5/2 will be easy. How do we integrate that 2 tan? Recall that tan is sine over cosine d theta, and then we're going to have 5/2 theta, and we'll tack on our plus c. We could say let u equal cosine of theta, then du will be negative sine theta d theta. So when we're substituting in, we'll have negative du in place of the sine theta d theta. So we'll end up getting 2 negative du over u. And that'll be negative 2 ln of absolute value of u. We're just going to carry along the other stuff. And what is u? So we have negative 2 ln of the absolute value of cosine of theta. Let's bring that 5/2 theta plus c. We'll just carry this down. And our original integral was in terms of x, not in terms of theta, so we need to get rid of this. What is cosine of theta? We go back to the original triangle that we drew. Cosine is adjacent over hypotenuse. There's multiple ways you could write this one. We could say negative 2 ln of absolute value 4 divided by the square root of x minus 3 quantity squared plus 16. Just make it look right. Plus 5 halves. Theta, since tan theta equals x minus 3 over 4, theta will be our inverse tangent of x minus 3 over 4. And we put a plus c. Now, if you did this on your graphing calculator for the 89s, it will not give you this one. But it is manipulation like we've spoken about in class, and you can use the log rules and take part of it and move it into the constant. Let's take a look at one more example. We'll say x over the square root of 7 plus 12x minus 4x squared. We need to get this as a perfect square. Let's leave the 7 alone. We'll have 7 minus, we want to factor that out so we can complete this square easily. So we'll have 4x squared minus 12x. And then plus what? You can go through this. This goes back to your Algebra 2 skills. Since we have this part will be 2x, and we know it's going to be minus something squared, this part over here is going to be squared, and the way we get our middle term is 2 times the first one times the second one. So that would dictate that 2 times 2x is 4x, times what gives us 12x, that would be times 3. So this is going to be 9. Since I added in 9 here, I actually really subtracted because there's a negative out in front of it. I'm going to have to add a 9 also inside that square root. So then the 9 and the 7 become 16, and we have x over the square root of 16 minus the quantity of 2x minus 3 squared, and then dx. Now we're ready to set up our right triangle. We have 16 minus, so that means 4 is the hypotenuse. We want the vertical leg to be 2x minus 3. And then using Pythagorean theorem, we get 16 minus the quantity of 2x minus 3 quantity squared. Let's start finding our information. We want what trig function is going to deal with the opposite and hypotenuse. That will be sine. So we'll have 4 sine theta equals 2x minus 3. Note, I could have started with sine theta equals 2x minus 3 over 4. I'm going to need that at the end, most likely. We'll see what happens with this. We can take the derivative, or find the differential. So we have 4 cosine theta d theta equals 2 dx. Let's move that 2 to the other side. So we have 2 cosine theta d theta, or just so there's no misunderstanding, I divided both sides by 2. Now we need the expression for the square root. That will be cosine. So 4 cosine of theta equals that square root stuff. Now we're ready to plug in. We notice here we have an x, so that means we're going to need to take this equation and solve it for x. We'll have 4 sine theta. Let's add 3 and then divide by 2, and we'll get our x value. So now let's plug that in. So we'll have 4 sine theta plus 3 all over 2 times dx, and dx is 2 cosine of theta d theta, all divided by the square root, which is 4 cosine of theta. Now we can look to simplify some of this. The 2's will go away. The cosine reduces out. We have 4 sine over 4. That'll give us just sine theta plus 3/4, and then d theta. So that worked out pretty nice. The antiderivative of sine would be negative cosine plus 3/4 theta, and then we have our c. What is cosine equal? We already know that's over here. So that will be negative of that square root, 16 minus 2x minus 3 squared, divided by 4. Over here we had the 4 already multiplied to the other side, plus 3/4 of theta, and theta will be the inverse sine of 2x minus 3 divided by 4. Put our plus c on it, and that's it. For this expression here, we could either leave it as 16 minus this quantity, or we could have written the original 7 plus 12x minus 4x squared. Either way is fine.